Hey guys, before we get started, I want to ask you a question. Are there any conditions that might increase the solubility of a substance? Meaning, what could you do to speed up how fast a solute dissolves in a solvent, right? I think about cooking a lot, and cooking and chemistry go hand in hand. So I think about having like a pot of water and pouring salt in it. What could I do to make that salt dissolve faster? There's a couple things you can do in the kitchen. You can add heat. Turning on the heat and warming up that water is going to help the salt to dissolve. The next thing you can do, and this is probably what y'all thought of first, is to stir it, right? Stirring the salt into that pot of water is also going to help it to dissolve more quickly. And then smaller particles, like when you think about the salt that you put into that water, it was probably really small crystals. It wasn't like a big hunk. So by creating those teeny tiny crystals, it makes it easier for that salt to dissolve in that water. So adding heat, stirring, shaking if possible, or creating smaller solute particles will all help to speed up how fast something dissolves. They all help to increase solubility. All right, so having said that, what the heck is solubility? Well, plain and simple, it's the ability of a solute to dissolve in a solvent. So it's the ability of that salt to dissolve in the pot of water, right? Fairly straightforward. Now, when it comes to solubility, there are three terms you're going to need to know about solutions that are created when you mix a solute into a solvent. And the first is saturated. So when you think about pouring salt into a container of water, at some point the water just can't hold any more salt, just no more will dissolve. So once you reach that maximum amount of solute that can dissolve, you've created a saturated solution. So a saturated solution is literally at the maximum amount of solute that will dissolve in that solvent, right? Now, so let's say we have a saturated solution and it takes 100 grams of salt. What if I only put in 50 grams of salt? I wouldn't be at the max. Instead, we call that solution unsaturated. And in some places you see it written as undersaturated, right? Unsaturated solutions are solutions that are not at the maximum solute levels. So you could still add more to it if you wanted, and it would still dissolve. However, you can go above that maximum. You can go above what we call saturated. And when that happens, the solution is considered to be super saturated. So you have more solute present than the solvent can hold. So if it takes, let's say, 100 grams of salt to make a saturated solution, that's as much as it can hold. If you put in 150, you're going to stir and stir and stir and stir, but it's never all going to dissolve. And that is a super saturated solution. So these three terms describe different types of solution. Saturated, you've reached the maximum capacity of solute. Unsaturated, you have not yet reached the maximum capacity. And then supersaturated means you've gone above the maximum capacity, right? The maximum amount of solute that liquid, that solvent can hold. All right, so keep those terms in mind as we move forward. Now, table G is the table for solubility curves that you're going to use in your reference tables. And it might look like table G is just a mishmash of lines, but as we work with it, as we practice it, or practice with it, I should say, it's going to be far more understandable, I'm sure. Okay, so here's not the slide I expected. So we're going to go one more. Here's table G just a little bit bigger. And I want you to see that Table G shows the solubility curves for a variety of different compounds, right? So for example, KNO3, which is right there. This is the curve for KNO3. So that curve, and only that curve, is the solubility curve for KNO3. Now, if we look at, let's say, NH4Cl, this is the curve for NH4Cl. So each compound has their own curve, and it's going to be important that you can kind of focus on only one line at a time. Now, this entire set of axes, right, because if you notice, that's what it is, right? There's a grid and there's curves that are drawn on this grid, much like, you know, plotting lines. If you look at this entire set of axes, you'll see that it is based on, or I should say, the x-axis is temperature, and the y-axis is solubility. So the x is temperature, y is solubility. So we're plotting x versus y. Okay? So kind of keep that in mind as we're going to move forward with this. Now, I'm going to go back to that other picture. There it is. So imagine this curve right here is the curve that's only for KNO3, right? We still have temperature along the x-axis here. And so we have temperature here. And we have solubility over here, right? So if you think about these as the x and y axis, and here we have a grid, right, with a whole bunch of different coordinates. If you were to plot any 2 points, and those 2 points, when you plotted them, landed directly on the curve, the solution you would be describing would be considered saturated. So for example, when it comes to KNO3, at a temperature of 50 degrees, right, and we hit the line right there, at a temperature of 50 degrees, right, we'd be looking at 90 grams of solute. So since this point lands directly on the curve, the solution we're describing here at 50 degrees and 90 grams of solute, that's a saturated solution. How do I know that? Because the point is directly on the curve. However, if we were to plot a point that landed somewhere above the curve, like up here, that would be considered supersaturated. Why? Because it's above the saturation line. Then again, if we were to look at something down here, we would consider that unsaturated. Why? Because we're below the saturation line. So what you're going to see is as we practice with Table G, for the most part, we're going to be looking at points that land directly on the curve. However, you might get a question that asks you about a point, a set of coordinates, that lands you either above or below the saturation line. So you need to know what you're looking at. If you're on the curve, it's saturated. If you're above the curve, you're supersaturated. And if you're below the curve, you're unsaturated. Okay? So as we practice with these problems, again, those 3 terms, kind of keep them in mind. So why don't we try a couple of questions, the likes of which you would see on a test and a quiz, and work with Table G. So, first question says, how many grams of KNO3, KNO3 is back, would be needed to saturate 100 grams of water at 60 degrees Celsius? Okay, so first and foremost, this entire chart only describes solutions with 100 grams of water. So 100 grams of water is standard for this chart. All right, having said that, I want to isolate the KNO3 curve. So here is KNO3. So this is the line we're looking at. Okay, the green one. So the question says, how many grams, now notice, grams is over here. How many grams of KNO3 would be needed to saturate this solution at 60 degrees Celsius? So what we're going to do is we're going to go to where it says 60 degrees on the temperature scale. And we're going to literally draw a line straight up till we hit the curve. Till you hit the line. And then you're going to draw a line straight across until you hit your till you hit your y-axis. Right there. And then you're going to estimate the value. So it looks to me like we're kind of smack in between 100 and 110. So I would estimate this to be 105 grams. So my answer to this question would be 105 grams. So it takes 105 grams of KNO3 to saturate an aqueous solution, a solution with 100 grams of water, at 60 degrees Celsius. Okay? And this is literally what we're going to do. We're going to isolate the curve that we're talking about, and then look at what coordinates they're asking about, and determine, is it saturated, super, unsaturated, what is it, or what numbers are they looking for? And you'll see, the more we do this, the easier it's going to get. Let's take a look at another one. How many grams of NH3 would be needed to saturate 100 grams of water at 10 degrees Celsius? Again, this entire chart refers to 100 grams of water, so we're kind of going to just ignore that for right now. Let's find NH3, which is here. So that means this curve, the purple one, is NH3. So now it says, how many grams of NH3, so we're kind of looking for the grams, we're looking for what's on the Y, are needed to saturate 100 grams of water at 10 degrees Celsius. So we are now going to go down to 10 degrees and draw a line straight up till we hit the curve for NH3, and then straight across, and this one happens to land, it looks like, right on 70. So I'd say that it takes 70 grams of NH3 to saturate a solution with 100 grams of water in it. All right, because remember, saturate means on the line. So this is how we're going to use table G. We're going to isolate the curve in question, and then we're going to use the information given, whether it's temperature or grams of solute, to find the missing value. Okay? So let's do a couple more. How about this one? This says, how many grams of sodium chloride would be needed to saturate 100 grams of water at 55 degrees Celsius? So remember, 100 grams of water is standard for this table. So here's NaCl, and here's the curve in question. Now it's asking us how many grams, so we're looking for what's on the Y, at 55 degrees Celsius. So 55 is going to fall smack in between 50 and 60. So we're going to draw a line straight up, well, as straight as I can get it, to the curve. And then we're going to kind of draw straight across. Sorry, my hand's a little shaky. So we're looking at something right about there. Now again, you're going to estimate. So it's between 30 and 40, but it's above halfway to 40. So I'm going to say like 37, maybe 38 grams. Okay, so the answer is 38 grams. So it takes 38 grams of sodium chloride to saturate a 100 gram solution of water at 55 degrees. Now, if you're off by a gram, if you came up with 37 or 39, totally fine, as long as you're in the ballpark. Because even on the chemistry regents, they give you a little leeway, like plus or minus 2 grams or something like that. Okay, but as long as you're in the ballpark, you should be just fine. Like your answer here could not have been 100, nor could it have been 5. Okay? Let's take a look at another one. At what temperature, you know what, I'm going to get rid of this ink so we can start fresh. At what temperature would 60 grams of NH3 saturate 100 grams of water? So, 100 grams of water, standard for the table. We're looking for NH3, so that's going to be this curve right here. Okay. Now it says at what temperature. So now they're looking for temperature. They're looking for the X. But they've given us the Y so we could figure this out fairly simply. Doing the same thing. At what temperature, don't know, would 60 grams of NH3. So you're going to go up your Y-axis till you get to 60, right here. Draw a line across till you hit the curve. And then you're going to draw a line down from the curve to your X-axis. Now, again, it's between, you got to estimate, it's between 10 and 20, but it's closer to 20. I'd probably say like 17 degrees or 18 degrees. I'll just say 17 for fun. All right, and we look at the answer. All right, well, the answer, according to the book anyway, was 16 degrees Celsius. But I'm at 17. I'm close. I'm really close. Okay? So again, as long as you're in the ballpark, you're good to go. So what you're going to need to be able to do is to look at this table, isolate the curve in question, and then use the information you're given to answer the question. Okay? So let's look at another one. This one says, what kind of solution is created by adding 40 grams of SO2 to 100 grams of water at 15 degrees Celsius? So here's SO2, and this is the curve for SO2. So now, let's look at the coordinates, at the points they're giving us. So, 40 grams and 15 degrees Celsius. So here's 15 degrees, and I'm going to go up until I hit the line for 40 grams, right? We're looking at this. So this is the point. Now the question asks, what kind of solution is that? Well, the point in question is above the saturation line, right? The saturation line here I highlighted green. So if the point is above the saturation line, we call that super saturated. Choice C. Okay? Remember, if you're above the saturation line, you're super saturated. If you're on the curve, you're saturated. And if you're below it, you're unsaturated. All right, let's do another one. What kind of solution is created by adding 110 grams of NaNO3 to 100 grams of water at 70 degrees Celsius? Okay. Remember, 100 grams of water, standard for the table. So now we're looking for NaNO3, which is right here. So it's this curve. Okay? No, it's not. I'm a liar. Sorry. So we're looking for NaNO3, I apologize, and this curve. There we go. So now, let's get the coordinates they're giving us. 110 grams at 70 degrees. So here's 70 degrees, and I'm going to go up the 70 degree line until I hit 110 grams, which is right there. Right, 110 grams, 70 degrees, right there. So tell me about this solution. Notice where the point is. It's under the saturation line. So is this solution saturated? Oh, I'm sorry, unsaturated? Saturated or supersaturated? What do you think? It's under the line. Yes, it is unsaturated. Well played. So I'm hoping this is becoming a little bit more comfortable for you using this table. Okay? The more practice you get with it, the easier it's going to be. Let's look at another one. Here we have how many grams of NaNO3 would be needed to saturate 100 grams of water at 40 degrees Celsius. So here's NaNO3. Here's the curve we need. The whole thing is 100 grams of water. So let's look at our specific coordinates. How many grams would be needed at 40 degrees Celsius? So here's 40. And I'm going to go up, till I hit the curve. And then I'm going to go across, which lands me, I'd say about 105 grams. Right? Looks about right. Smack in the middle between 100 and 110. Lo and behold, the answer is 105. That one wasn't too bad. So, what about if we had 200 grams of water? Now remember, this whole table gives us values at 100 grams of water. So, if you look at the question we just did, for 100 grams of water, we would need 105 grams of solute. What if we had 200 grams of water? Think about it. What did we do to get from 100 to 200? You had to multiply it by 2. So what do you think you're going to do to that 105? The same thing. So if you double the amount of water, but you still want it to be saturated, you're going to have to double the amount of solute you put in. So this chart is for 100 grams. You can find your answer for 100 grams. But now the next question asks, what about at 200 grams? So you're going to have to double your answer. That kind of makes sense? Right? Remember when we talked about even conservation of mass? How if whatever you do to one side, you have to do to the other? Well, it's rather similar. All right? So, go to Google Classroom, work on the exit ticket, do your best. That's all I can ask. And if you have questions, please email me or, quote unquote, meet me during our scheduled class time. Okay? Have a great night and be well.